purpose of this video is for you to be able to explain the connection between Albert's equation and stars. Now, ice and water are both hydrogen and oxygen, H2O molecules. And they're essentially the same thing, except the phase is different. Now, gold in the electromagnetic spectrum, it's a little bit different about what about how these two things are related. They don't seem related, but they really are. Because Einstein came up with the idea that mass could be converted into energy, and vice versa. And mass and energy were really two forms of the same thing, or two things that were like just different ways of presenting itself. And therefore, things like gold or anything that's matter is essentially energy. And energy in a way could be changed back into something like gold, or like a guitar, or a telephone that's ringing. Now, this is related to a star, because in a star, like our sun, they fuse matter in the core. And this fusion converts the hydrogen into helium, but in the process, some of the mass gets converted into things like electromagnetic waves. And that gets shot out and transformed into other things like heat, visible light, UVs, all those other types of rays, and other forms of energy. Now, Einstein came up with the equation for this transformation, and he came up with the idea that the energy is equal to the mass times the speed of light squared. Now, in this equation, E is energy, M is mass, C is the speed of light, E is in joules, J, capital J, M is in kilograms, and C is speed of light, 3e to the 8th meters per second. And that's going to calculate, whenever you convert mass, how much you're actually calculating, how much energy you're actually creating. Let's take this problem. Half a kilogram. You want to know how much energy we're going to have created. So, first thing I'm going to do, I'm going to figure out what I know and what I don't know. I know I want my energy. I know that's how many grams I've got, and that's the speed of light. Now the grams, I'm going to need to convert it to kilograms, so I draw the bracket. I put the 450 grams in the top left, and then I know that there's 1,000 grams for 1 kilogram, so 1 kilogram is 1,000 grams. And then I would multiply across, so 450 times 1, all over 1,000, and I'm going to cancel out the G's, and that's going to be 0.454 kilograms. The next thing I need to do is, in the 4-step format, is to write the formula, and my formula is energy equals mass times the speed of light squared. And then I'm going to plug things in. All right, I'm going to plug in my converted factor, or converted piece of mass. And then I'm always going to square the speed of light first. So 3.00 e to the 8th times itself. That's 9 e to the 16th times this. So I'm going to really rough 9.5, so it's going to be like 0.4 or something, and I'm going to solve it. When I multiply that in a calculator, that's what I get 4.06 e to the 16th kilograms meter squared second squared. These should be superscripts. I didn't do that. And then I'm going to round for sig figs. These both have 3, so my answer would have 3, so it's going to be 4.09. And these 3 things, 3 units, all go into a joule. So that's how much, and that's a lot of energy.